What's up guys, it's Imran Fiaz and today's video is on AQALS AS Level Chemistry June 2021 Paper 1 walkthrough. Before I even carry on, the reason I'm posting all these AS level videos, posted 2 already, or by whatever time you're watching this video, because I've gone through all the A level papers a couple of weeks ago in preparation for my mocks, and alhamdulillah they went very good. And now I'm going to go through the AS level chemistry papers during the half term. And obviously, once I've got this done, then I'll switch back to the A level papers and switch back to the AS level papers and keep doing that. And the multiple choice questions, because I'm only doing section A's for these papers, I probably will maybe do like maybe 5 multiple choice questions a day, and then over time, gradually that will build up. But anyway, question 1: state 2 features of current model that are not shown in the Rutherford model. Well, the current feature 1 of the current model includes neutrons and protons, and it shows current model shows electrons in different energy levels / orbitals. There you go. 2.1 gives a symbol including the mass number of the ion that reaches the detector. First, it's going to be 10. So 10 is, what's that? Yeah, so 10 is going to be Sn. It's an ion, and it's analyzed time of electron impact from 1 plus ion, so it's going to be Sn plus 112. So 112 Sn plus. Calculate relative atomic mass in the sample. So the percentage abundance must add up to 100. So what I'm going to have to do is here, let me zoom out a bit so I can see all the percentage abundances. 100 minus 22.41 plus 11.78 plus 34.97. That will give me the percentage abundance of the 120, and then I can quite easily work out the relative atomic mass. So 100 minus 22.41 plus 11.78 plus 34.97. Yep, and I get 30.84. And therefore the relative atomic mass is going to be 112 times by 22.41 plus 114 times by 11.78 plus 117 times by 34.97 plus 120 times by 30.84 divided by 100. I get 116.5%. Which doesn't look correct, because why would it be greater than 100? But it is the correct answer, 116.1%. State 1 observation: magnesium reacts with steam, given the equation. So I'm going to go for the equation first because I'm more confident with that. Mg solid plus H2O gaseous to form MgO solid plus H2 gaseous. So I'll form magnesium oxide when magnesium reacts with steam. Observation: bright light. Bright light, white light, Mg solid plus H2O gaseous, MgO solid plus H2 gaseous. Describe bonding in magnesium. There's attraction between lattice of Mg2 plus ions, or you could say cations because positive charge ions, and delocalized electrons. So attraction between that, Mg2 plus ions, lattice of that, and the delocalized electrons. Explain in terms of structure and bonding where magnesium chloride has a high melting point. Again, giant ionic lattice, strong electrostatic force of attraction, and then the final part, you really need to apply it to the question. You can't just say that and get away with it. Between oppositely charged ions, it would give you that, but I would just say I've got Mg2 plus ions and Cl minus ions, so between Mg2 plus ions and Cl minus ions. Because you don't know if the mark scheme is going to be that specific it wants you to. Because if you say oppositely charged ions, you could play that's really general. So giant ionic lattice, strong electrostatic force of attraction between Mg2 plus and Cl minus ions. Give one medical use for magnesium hydroxide, indigestion tablets, indigestion relief, yeah, indigestion relief. Say in terms of electron meaning with the term oxidizing agent, this came up literally, I think it was last past paper, maybe past paper ago, the 2023 one. Oxidizing agent equals electron acceptor. They always like to ask the definition for this, so definitely memorize it. Oxidizing agent, electron negatively charged, electron acceptor. Use the half equation for the oxidation of this SO3 2 minus to SO4 2 minus. Half equation for reduction of this to Cr3 plus ion. And then the overall equation. So SO3 2 minus to SO4 2 minus. I just need to add a H2O here. Then I need to add 2 H pluses here. And then I need to add 2 negatively charged electrons here. And everything balanced. 1 sulfur, 1 sulfur, 4 oxygens, 2 H plus, 2 H plus. Charges are not balanced, are they? No, they are balanced. Yeah. Half equation reduction to Cr3 plus. First thing you need to identify, I've got 2 here, I've only got 1 here, so I need a 2 here. Then, okay, I've got that. Well, I need 7 H2Os because I need 7 oxygens. I can only add oxygen by adding water molecules. I've got 14 H pluses, so I need to add 14 H plus here. And then look at the charge. Well, this 2 Cr3 plus, well, I've got a Cr3 plus, but because I've got 2 of them, the overall charge is just going to be 2 times by 3, which is 6 plus. So I've got plus 6 on the right hand side, plus 12 on the left hand side, so I need to add 6 negatively charged electrons on the left hand side. Then I need to do overall equation 1 times by 3, because I need this to be the same, these negatively charged electrons. So if I times it by 3, I get 3H2O plus 3SO3 2 minus, out of 3SO4 2 minus, plus 6H plus 6C minus. So I'm going to have 3H2O plus 3SO3 2 minus plus 14H plus Cr2O7 2 minus. Now obviously in the exam do your forward arrow that way, but I can't because I won't have enough space. I'm just going to have to do it like this. To 3SO4 2 minus plus 6H plus 2Cr3 plus 7H2O. Did I do it correct? Times that by 3, you get that, plus that. Then you form that, and that, and that, and that, and the negatively charged electrons cancel out. That's the whole point of timesing it by 3. Yes. So electron acceptor, perfect. Oxidizing agent, electron acceptor. Just keep remembering that. H2O plus SO3 2 minus SO4 2 minus plus 2H plus 2 minus, perfect. 6E minus plus 14H plus Cr2O7 2 minus form 2 Cr3 plus 7H2O. 3. Oh my days, I made that same mistake again. It's so easy to make as well. Is everything balanced? Well, I can't divide by 3 because I've got 14. But what I can do is, does anything appear on both sides? Yes, it does. What is it? The 14H pluses and the 3H2Os. And that's why I was like, why is there so many, reactants and products? These cancel out. So that goes and that goes. So I get 3SO3 2 minus plus 8H plus plus Cr2O72 minus to form 3SO42 minus plus 2Cr3 plus 4H2O. And there you go. And the thing about these questions is that the 1 mark for each one. So if you don't get exactly in its simplest form with you cancelling the H2O molecules out and cancelling the H plus ions out, you won't get that mark because it's 1 mark for each one, right? And that's just a shame. But luckily now I know what to do next time. Such the identity of the positive ion in solution A. Positive ion in solution A. White precipitate with H2SO4. Warm sodium hydroxide, no visible change. Give me an equation with information of white precipitate in test 1. For solution A. Suggest the identity of the positive ion solution A. Solution A, the positive ion, warm sodium, no visible change, so I don't really care about that. White precipitate with sulfuric acid. Oh, right, so it's going to be the Ba2 plus ion. Yeah, the Ba2 plus ion. And then ionic equation, formation of the white precipitate, Ba2 plus ion, aqueous plus SO42 minus aqueous to form barium sulfate solid, BaSO4 solid. Different gases are formed in solution B reacts in test 1 and test 2, suggest identity of each gas. Different gases are formed in solution B reacts with test 1 and test 2. Effervescence gas formed in test 1. Effervescence is carbon dioxide gas. The gas formed in test 2, gas formed that turns damp red litmus paper blue, NH3. Ionic equation for the formation of the gas in test 2, NH4 plus aqueous. Actually, didn't even ask me for the state symbol, so why would I give it? Plus OH minus from NH3. I guess you could, but that's fine. Carbon dioxide, NH3, NH4 plus aqueous plus OH minus aqueous, NH3 gaseous plus H2O liquid, and it says ignore state symbols. Yeah, because it didn't tell me to do that. Describe further test to show whether solution C contains chloride or bromide ions. Solution C contains chloride or bromide ions. So we're going to add dilute ammonia solution. A dilute ammonia solution. If the precipitate dissolves, chloride ions are present. If the precipitate does not dissolve, then bromide ions are present. Chlorine has a low boiling point because the forces between molecules are weak. Spain has forces that arise between molecules of chlorine, and it's talking about okay, so random movement of electrons in one molecule induces a dipole in the neighboring molecule. Neighboring molecule. These temporary dipoles attract, hence temporary attraction between partially positive and partially negative. given the equation reaction of chlorine with water, Cl2 plus H2O, reversible reaction, HCl plus HClO. Or you could say 2Cl2 plus 2H2O form 4HCl plus O2. Reason is added to drinking water kills microorganisms. Chlorine reacts with cold aqueous sodium hydroxide manufacture bleach given equation of reaction. Chlorine plus 2 NaOH plus 2 sodium hydroxide to form NaCl plus NaClO plus H2O. And again, this equation, both these equations you need to memorize off by heart. Cl2 plus H2O, reversible reaction HCl plus HClO. Cl2 plus 2 NaOH, RO, NaCl plus NaClO plus H2O. Show that calcium sulfate is a limiting reagent. Calculate mass in grams of sulfur dioxide formed. And how many other questions are left? Question 6. So what I'd have to do first is find out the moles of CAS, which is 2.50 of the MR, and 2.2. Then find out the moles of calcium sulfate, 9.85 the mass of the MR, 6.2. And then once I've got these values, no 0.0346, no 0.0723. I want to show calcium sulfate is limiting region in this reaction because it is a 1 to 3 molar ratio. So therefore, the expected moles 0.0346 times by 3 is 0.1038, but it's not. It's 0.07. So show the moles, show them, and then say 3 moles of this so 3 moles of CaSO4 needed for 1 mole of CaS, needed for each mole of CaS, and then say the number of moles of CaSO4 is not equal to the number of moles of CaS times by 3. Therefore, CaSO4 is a limited region. Calculate mass in grams of sulfur dioxide formed. Well, then why would I show that is limiting region and then calculate mass? So I'm going to use these moles. So the number of moles of calcium sulfate, 0.0723, times by, well actually, I like to do this instead, divided by 3, times by 4, and then moles is mass over MR, mass is the moles, times by sulfur dioxide, which is 32.1 plus 16 plus 16, and I get 6.18. Always think about, these kind of things, these mathematical calculation questions. Why would it want me to show calcium sulfate is in limiting region in this reaction and then calculate the mass of sulfur dioxide forms? So show its limiting region, 3 moles needed for each mole of this, and it's clearly not 3 times the number of moles of CaS or CaO. and then use those moles of calcium sulfate to work out the number of moles of sulfur dioxide, and then hence the mass of sulfur dioxide. Say the meaning of this term: standard enthalpy of combustion. Enthalpy change when 1 mole of a substance burns completely in oxygen with all substances in their standard states. Enthalpy change: 1 mole of substance burns completely in oxygen with all substances in standard states. 25 degrees Celsius and 100 kilopascals. Calculate value for the enthalpy of combustion propane 1 in this experiment. And a lot of A-level questions, like this AS level paper, are very similar to this, but they won't directly tell you the mass of water. They would say the density is 1 gram per centimeter cubed, and then you'd have to then work out the mass by just adding the volumes up. But apart from that, it's very similar. So Q equals mc delta T, where M is a mass of water, and I know mass of water is 150, so Q equals 150 times by 4.18 times by temperature change, which is 35.1 minus 21.2, 13.9. But I want delta H in kilojoules, so then I need to divide that by 1,000, whatever that is. And then the moles is the mass over mR. Again, the mass. In this case, the mass is not of water, the mass is of the alcohol. And you need to know these tiny details, otherwise you would lose significant marks, because if you don't know what the mass of which is, then you're going to get it wrong. So times by 13.9, so I'm working out Q now, 150 times by 4.18 times by 13.9, and then divide my answer by 1,000, because I want my answer in kilojoules multiplied by 1, so I get 8.7153 as Q, divided by the number of moles, which is going to be the mass of propane 1 0.497, divided by the MR, which is 60. And again, this is another thing in the A-level paper, they won't directly give you the MR a lot of the times. You'd have to work it out yourself. And it wouldn't just be like propane 1, it'd be like a carboxylic acid or something, or an ester, and you'd have to work out the MR of it, and it won't give you the formula as well. That's the difference between the A level and the AS level questions. Just a tiny bit more difficult. So divided by my answer, then 8.7153 divided by my answer, 1052. But I know temperature increases, so therefore it's got to be exothermic, so negative. Perfect. Minus 1050. Give one of the possible reasons of this other than heat loss. Enthalpy is less exothermic. The idea: incomplete combustion, evaporation of fuel. But yeah, incomplete combustion is that. Well, don't say evaporation of fuel, say evaporation of the alcohol. Or you could say evaporation of fuel. Uses the results, calculate mean titer, and then a 6 marker, okay. But that's it for this part, really. So calculate mean titer, so concordant titers, so these two, 20.25 plus 20.30 divided by 2, 20.25 plus 20.30 divided by 2, 20.275, well, I'd say 20.28, since all of these are to 2 decimal places, yeah, but yeah, 22.275 is the correct one. So then it says, calculate percentage by mass sodium ethanoate in the original sample. I've got this much of sodium ethanoic acid contaminated with sodium ethanoate. Perfect. I want to dissolve sample, makes the volume up to this, removes this much, attaches them with this much sodium hydroxide, so I can find out the moles of that. Then, so I find out the moles, 25 divided by 1,000 times by 0.350. then times by 8 to make up 200 centimeters cubed. But that won't really then make sense. Then why would I? Why would I calculate mean titer and then use a different volume? Remove 25. Okay, so first thing I need to do is use the mean titer value. So the moles of sodium hydroxide is 20.275 divided by 1000 times by 0.350. And that is the moles in 25 centimeters cubed. Then I need to times it by, well, 200 divided by 25, so I need to times it by 8. So 20.275 divided by 1000 times by 0.350 times by 8. That's my Newmark moles. And that's 1-to-1 mole ratio. So that's the moles then, therefore, of the ethanoic acid. 0.05677 moles of the ethanoic acid, obviously in 200 centimeters cubed. Ethanoic acid in 200 centimeters cubed. Then I'm like, okay, I've got the moles. Moles is mass of MR, right? So what's the mass? The moles times by the MR of ethanoic acid, which is 24, 27, 32, 33, 60. Then, okay, so then you get, so 60 times by 1.05677. Then I get 3.4062. And what is that the mass of? That's the mass of ethanoic acid. I want to find out the percentage by mass of sodium ethanoate. Then I do 5.60 minus my answer. That's the number mass of sodium ethanoate over the total mass. 5.60 times by 100. 39.2%. So calculate mean titer value pretty easy. Then realize, why would I use this to calculate moles? I need to use this to mean titer value. Why else would I work it out? Use the mean titer value to work out the moles. Once I worked out the moles, then it was 1-to-1 mole ratio. That's moles of ethanoic acid. 25 centimeters cubed on 200 centimeters cubed. So then times it by 8. Then that's the moles in 200 centimeters cubed. Then I can work out the mass. But then that's the mass of the ethanoic acid, because I times by the mol of ethanoic acid. Then I do 5.60 minus the mass of ethanoic acid to find out the mass of sodium ethanoate. And then I do that over the total mass, 5.60 times by 100, because the percentage to find out my final answer. Student rinses the burette with deionized water before filling with sodium hydroxide. Solution state effect, state and explain the effect and the value of titer. Titer value would increase because the sodium hydroxide solution would be more dilute. Titer value would increase because sodium hydroxide solution would be more dilute. Explain in terms of equilibrium yield why these conditions are used. I need to really hurry up now because I get to eat, but I just want to get this video out the way. Temperature. The reaction is endothermic. Equilibrium shifts to the right hand side to reduce the temperature. So higher temperature increases the yield. If I increase the temperature, it's going to shift to the endothermic direction to oppose increased temperature, so it increases the yield. However, high temperatures are costly, so a compromise compromise temperature is used. And I give example 500 degrees Celsius, for example, instead of 800. Stage 2, the pressure, a low pressure of 300 kilopascals. Well, I've got more moles of gas. Well, more moles of gas on the right hand side. So equilibrium shifts to side with more moles of gas as I reduce the pressure to increase the yield. So a lower pressure increases the yield. However, a low pressure means a low cost. But then what I would also say is a low pressure means reaction is too slow. Hence, a compromise pressure is used. For example, 500 kilopascals instead of 300. Stage 3, the nickel catalyst. The catalyst or catalysts have no effect on the yield. That's a fact you should know it by heart. So adding a catalyst allows a lower temperature to be used. It does temperature to be used, so lowering the cost. So it's really just using the information it's giving you. Polar reactions endothermic. More moles of gas on the right hand side, only 2 here. So reactions endothermic, equilibrium shifts to the right hand side to reduce temperature. So high temperature increases yield. High temperatures, however, are costly, so compromise temperature is required. As you use pressure, again, low pressure means high yield, increases the yield. Low pressure means low cost. However, low pressure means reaction can take too long. It might take a couple of days instead of a couple of hours or a couple of weeks. I don't know. So compromise pressure is used. Catalysts have no effect on the equilibrium yield. Adding a catalyst, however, will lower the temperature to be used, so lowering the cost. Question 10, give expression for the equilibrium constant Kc. Kc is square brackets. So square brackets of product SO3 squared divided by SO2 squared times by O2, your reactants. Calculate the amount of moles of oxygen at equilibrium. At equilibrium mixture contains this much of sulfur dioxide, this much of sulfur trioxide. I want to find the moles of oxygen at equilibrium. And what I can do then is rearrange the equation. Yeah, that's what I would do. Kc. Then I'm just going to substitute my values in because I really get to E. Rod D. So SO3 0.461 sulfur trioxide divided by 1800 centimeters cubed. I want a moles per minus cube, so that's divided by 1000. So 1.80 squared divided by SO3 squared, right? Yes. Divided by SO2, which is squared sulfur dioxide, 0.176 divided by 1.80 squared times by Kc 15. That gives me the concentration of oxygen. I want the moles concentration. So my answer, concentration times by the volume, which is 1.80 in moles per minus cubed. I get 0.823. Perfect. 10.3 different temperature mixture contains this much. Total pressure is that. Use data to calculate temperature in degrees Celsius of the mixture. Temperature of the mixture. and I'm given this was a bit more tricky. Ideal gas constant is that. Why would it give me ideal gas constant? Oh, I'm going to have to use PV because nRT. So I need to spot that firstly. I want to find temperature, so T equals PV divided by NR. I've got the pressure, I've got the volume, the number of moles. I've got, and R I've got, and then that will give me temperature in Kelvin, and then I minus 273 to get the temperature in degrees Celsius. Okay, so pressure 255,000 times by the volume, but in meters cubed, so 3,500 times by 10 to the power minus 6, divided by N, the number of moles, 0.025, plus 0.049, plus 0.034, times by 8.31. But that's the temperature. Is that the temperature in Kelvin or degrees Celsius? That is the temperature in Kelvin. Oh, I've done something wrong. I wrote 0.49 moles, it's 0.049 moles. 994, that's perfect, so I get temperature as 994 Kelvin, and then I want it in degrees Celsius, and then minus 273. So then minus 273, I get 721 degrees Celsius. Perfect. So you can see how they can interlink topics. Ideal gas equation and equilibrium constant Kc. So find out total number of moles, use PV because nRT, N is PV divided by RT, substitute the values in, get temperature in Kelvin, subtract minus 273 to get the temperature in degrees Celsius. And that is the end of section A.